Hello, Algebra 2. We're going to do the next section here. We're going to do the section called complex fractions. So if you look in your notes, a complex fraction is a fraction in which the numerator and the denominator both contain fractions. So it's a fraction over a fraction. To simplify a complex fraction means to rewrite it as a single fraction with no fractions in the numerator or denominator. So here's the steps we're going to use. We're going to create a single fraction in the numerator and a single fraction in the denominator. Then we're going to set it up as a division problem because a fraction is division. And we're going to multiply the numerator by the reciprocal of the denominator. And then we're going to simplify. All right, so I'm going to do the first the first 8 examples. All of these already have step 1 done for you. It's a single fraction in the numerator and a single fraction in the denominator. I'm going to do all 8. You do not have to do all 8. If I do a couple and you think, oh, I got this, you can just fast forward and move on to the next part. But I'm going to put all answers down so that you can check them if you want to do them. Okay, so for number 1, we've got 1 fraction in the numerator, 1 in the denominator. So we're going to set it up. We're going to take the numerator and multiply times the reciprocal of the denominator. We're just going to flip it over. And then we're going to simplify just like we have in our other sections. You can write this as 4a over 2a squared. So then we'll go ahead and we'll cancel things. 2 goes into there once, 2 goes into there twice. 1a here, we'll get rid of that there. And we end up with 2 over a as our answer. Right? That's the technique we're going to use. Let's look at number 2. We're going to take the numerator and multiply it by the reciprocal of the denominator. Then we're going to multiply straight across, and we get 48x cubed over 3xy squared. And let's see what we can cancel. 3 goes into there once, 3 goes into there 16. We can cancel this x on the bottom, and we're left with 2 there, and the y's have to stay. So we're left with 16 x squared over y squared. And that's your answer. All right, let's look at number 3. 18p over 8p minus 2 times 4p minus 1 over 4p squared, reciprocal of the denominator. Now we're going to have to do some of those techniques like we did in the last section. These are non-monomials, so we're going to factor each part. Nothing we can do here, nothing we can do there. But look right here. We can factor out a 2, so we're left with 4p minus 1. Okay, you do not want to multiply straight across like we did in number 1 and number 2 if you have binomials or trinomials. You want to keep them just as factors. And now we're going to see what we can cancel. 4p minus 1, 4p minus 1. 2 goes into here once, 2 goes into there 9 times. We can cancel this p with one of those p's, and what are we left with? We're left with a 9 in the numerator and a 4p in the denominator. And that's our answer. Number 4, k minus 1 over k times the reciprocal, k squared over k squared minus 1. We got to factor that. So we're going to get the first one is going to stay the same. K squared minus 1 factors to k minus 1, k plus 1, because it is a difference of 2 perfect squares. What can we cancel? We can cancel k minus 1. We can cancel this k with that, and we're left with k over k plus 1. And that's our answer. Nothing else we can do. Okay, let's look at number 5. They're going to get a little bit more complicated in that there will be more things to simplify. So let's see if I can fit it all in here. So there's number 5. When I take the reciprocal, the only thing that I'm going to be able to factor or simplify here is the 7c plus 35. We can factor out a 7, and we get a c plus 5. So what can we cancel? C plus 5, C plus 5. This C and that. So we're left with 7C for our answer. Nothing in the denominator. Everything crossed off in the denominator. All right, number 6. This one's going to be a little bit complicated. B plus 2 over B squared plus 6B plus 8 times B squared minus B minus 20 over 1. So let's see what we can factor. B squared plus 6B plus 8, we're going to say what multiplies to give you 8 and adds to give you 6. That's going to be a 4 and a 2. And then over here, we're going to say what multiplies to give you negative 20 and adds to give you negative 1. That's going to be a 4 and a 5. The 5 is going to be negative. The 4 is going to be positive. So what can we cancel? B plus 4, B plus 4. And what are we left with? B plus 2, B plus 2. What are we left with? B minus 5 for the answer. Again, all the denominator gets canceled away. All right, let's look at number 7. 15 plus 5r over 15r squared times 12r minus 12. Whoops, I did that wrong. Times 1 over 12r minus 12. Because this is like 12r minus 12 over 1. So we're going to take the reciprocal of that, and it becomes this, what I have written over here, 1 over 12r minus 12. Now, what can we factor? We can factor a 5 out of that. And we can factor a 12 out of that. What did I do wrong? Oh, this is a 15. Whew. That makes sense. That should be a 15. This should be a 15, which means this should be a 1 plus r. A 1 minus r. Goodness, I have everything wrong here. Let me just start over. This is a 15 minus 15r. So this is 15 minus 15r. There, now we have it. And what can we cancel? 5 goes into there once, 5 goes into there 3. Can we cancel 1 minus r and r minus 1? Yes, we can, but only if we stick a negative out in front somewhere. So in the numerator, we end up just with negative 1. And in the denominator, we end up with, this is me again. There should be a 15 there. So really those just cancel, those two 15s. I'm sorry, I messed this one up. In the denominator, we have a 12 and an r squared. That was a little confusing. I'm sorry. If you have more questions on that, just let me know. All right, let's look at number 8. This one, I'm going to factor out a 2 when I rewrite it. And in the bottom, I'm going to factor out a 3. And then when I take the reciprocal, I'm going to factor out a 9m. And up here, I'm going to take out an m squared. Okay, so I still need to factor this m squared minus m minus 20. So I'm going to go down here where I have more room, and I'm going to say what multiplies to give me negative 20 and adds to give me negative 1, and that's going to be negative 5 and plus 4. And then I have a 3m plus 4, and I have a 9m, m plus 4, and I have an m squared, m minus 5. So let's see what we can cancel. We got an m plus 4 and an m plus 4, m minus 5, m minus 5. We got this m with that m. 3 goes into there 1, 3 goes into there 3. So in the numerator, we end up with 2 times 3, which is 6, m plus 4, right here. And in the denominator, we're just left with this 1m. And that's our answer. We cannot cancel these m's. No, 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 do not do that. Because you can only cancel things when they are multiplied together. We could cancel, whoops. We could cancel a 6 with something. We could cancel an m plus 4, but we can't just cancel the m's. That does not work. Don't fall into that trap. All right, let's look at the next one. Number 9. Now we have to do that first step, okay? We got x minus 3 minus 3 over x minus 3 over x. Lots of x's, lots of 3's. Okay, now we have to do the first step. The first step is having one fraction in the numerator and one in the denominator. Our denominator already has just one fraction, but look at this. Our numerator has 2. So we have to rewrite our numerator as one fraction, which means we have to get a common denominator, which is going to be 3x. So we have to multiply this one by 3 over 3, and this one by x over x. And if we do that, we end up with x squared minus 9 over 3x. That's just our numerator. We still have this in our denominator. Now we're going to do, now we've got one fraction in the numerator, one in the denominator. So we're going to take the numerator and multiply times the reciprocal of the denominator. We're going to factor. This is a difference of 2 perfect squares. And we got this. And what can we cancel? X minus 3, x minus 3, x, x. And we're left with x plus 3 over 3. Can we cancel those 3's? No, because this 3 is only added. It is not multiplied. We cannot cancel it. Okay, let's look at number 10. 1 over PQ over 1 over P minus 1 over Q. Okay, we got to do the same thing we did in number 9, except our numerator already is 1. Now we have to change our denominator. And our common denominator is going to be P times Q. So we have to multiply this one by Q over Q, and this one by P over P. And that equals Q minus P over PQ. Take our numerator, multiply it by the reciprocal of our denominator, start crossing things off, and we're left with 1 over Q minus P. And that's our answer. See, this isn't so bad. All right, let's look at number 11. 5/4 over 20 over n, thought it was an M. Looks like it's an N minus 4 minus 5 over 4N minus 16. All right, now we've got, let's just look at the denominator. We don't have to really worry about the numerator because it's already just one fraction, so it's just going to stay there. But let's look at our denominator. This right here is just like a problem that we did in one of the first sections of this chapter. So we have to find a common denominator. So we're going to factor, this one's already factored. Here we're going to factor out a 4, and we get n4 times n minus 4. So our common denominator is going to be 4 times n minus 4. So this one we have to multiply by 4 over 4. And we get 4 times 20, which is 80 minus 5 over 4 times n minus 4. I'm going to leave it factored because we are going to need to factor it in the end anyway. So this is going to be 5/4 times, now take the reciprocal, 4 times n minus 4, and 80 minus 5 is 75. And then we got to see what we can cancel. We can cancel the 4s, and 5 goes into there. 1, 5, 6, 7, 15 times. And our answer is n minus 4 over 15. And that's our answer. All right, whoops. Let's look at number 12. Number 12 is w over w plus 2 over 1 minus w over w plus 2. All right, numerator, already one fraction. Denominator, we're going to have to write this 1. I can rewrite this 1 as w plus 2 over w plus 2. Okay? You can always put the same thing over each other to get 1. So now we have a common denominator, so we're going to have w plus 2 minus w over w plus 2. So we got our numerator times the reciprocal of the denominator. What does this equal right here? W minus w is 0, so it just equals 2. What can we cancel? Cancel those, and we're left with w over 2. Number 13. Oh my goodness. 1 over a squared minus 1 over b squared over 1 over b plus 1 over a. Now we've got to find a common denominator both in the numerator and the denominator. What's going to be our common denominator in the numerator? A squared times b squared. So this one we have to do b squared over b squared. This one a squared over a squared. So our numerator becomes b squared minus a squared over a squared b squared. And in the denominator, our common denominator is going to be a times b. So this is going to have to be a over a and b over b. So that equals a plus b over ab. Now let's do our reciprocal thing. B squared minus a squared over a squared b squared times ab over a plus b. And we have to factor this b squared minus a squared. It is a difference of two perfect squares. B minus a, b plus a over a squared b squared times ab over a plus b. And let's see what we can cancel. We can cancel those because b plus a and a plus b are the same thing. Here we have 1a, we can cancel that. 1b, cancel that. And we're left with b minus a over ab. And that is our answer for that one. Okay, let's look at number 14. Number 14. m over n minus 1 over m over n plus 1. Okay, what is going to be our common denominator? N. So this we're going to have n over n. This we're going to multiply by n over n. So we get m minus n over n over m plus n over n. And if we take our numerator, multiply it times the reciprocal of the denominator, what can we cancel? We can cancel those. Can we cancel m minus n and m plus n? No, we cannot. So we're left with m minus n over m plus n for our answer. Okay, 2 more. Number 15. 1/4 plus 1 over 4v over 1 over v plus 1 over 4. What's going to be our common denominator in the numerator? 4v. So we just got to do this. And that becomes v plus 1 over 4v. And in the denominator, the new common denominator is also going to be 4v. So this one we have to do 4 over 4. And this one we have to do v over v. And we get 4 plus v over 4v. And we take our numerator and the reciprocal of our denominator. Now when I say you can't cancel things if they're not multiplied, this is multiplied by this, and this is multiplied by this. Everything is multiplied here. So we can cross these off since they're exactly the same, and we're left with v plus 1 over 4 plus v. This should be a v, not a 4, right? 4 plus v, right there. Okay. And the last one, of course, it will be the most involved. A squared over a plus 3 times a squared over 5a plus 15 over a over a plus 3 plus 1/5. So in order to do this in the numerator, just right here, this is like one of those problems that we've had in the last chapter, or the last section, not the last chapter. So we have to factor the denominators to find the common denominator. That's already factored. What does this factor as? This factors as 5 times a plus 3, if I factor a 5 out. So then we know that over here, all we have to do is multiply by 5 over 5, and then they have the same denominator. So our numerator becomes 5a squared, and oh, my computer went off. This is actually a plus. So we have 5a squared plus a squared over 5 times a plus 3. And in the denominator, we're just going to have to multiply this by 5 over 5 and this by a plus 3 over a plus 3. And we're left with 5a plus a plus 3 over 5 times a plus 3. And now we're going to do our reciprocal thing. But look at this. 5a squared plus a squared is 6a squared over 5 times a plus 3. Taking the reciprocal in the denominator, we get 5 over a plus 3. 5a plus a is 6a plus 3. So what can we cancel? 5, 5, a plus 3, a plus 3. And we have 6a squared over 6a plus 3. Are we done? No, we are not done, because we can still factor the denominator. We can factor 3 out, And we can say 3 goes into there once, 3 goes into there twice, and we're left with 2a squared over 2a plus 1. And that is your final answer. Let me see. Yep, that's your final answer. So right here, you could say, you can only cancel things if it goes into every single part. There are 3 parts right here, and 3 goes into each of those. 3 goes into here once, 3 goes into there twice, 3 goes into there twice, and you left with 2a squared over 2a plus 1. So you can think of it like that, or what I did right here where I factored a 3 out of the denominator. All right, that's the end. Complex fractions. See how you can do on the homework.